All right, guys, welcome to lesson 1.0 and 1.1 from your AP Stats textbook. This is for anybody that needs some additional reinforcement of the concepts in those two sections of the textbook, which you are able to get now from the school if you come pick them up. So we're going to go ahead and get started on a couple things that are going to be helpful for you to be able to do your sapling assignment. So we'll start with, I'm going to share my work. And we'll go with a new share. And we'll go with screen. All right, so you should hopefully see this screen. I'm going to make it a little bit bigger now, but I'm going to adjust the size of it later to be able to input some data into a website. Okay, so in section 1.0, we want to talk about individuals versus variables. Individuals are people, or basically the small items that you get the data from, and then the variable are the different categories. It's the what. So the individual's the who, the variable's the what. Important to know to be able to recognize the difference between them. So let's imagine a problem where you were doing a survey of some people, and this is a group of 80 people. You can add these up to verify that you surveyed, and you asked, what are your favorite elective classes? And this is the numbers that we got. Okay, a lot of people like PE, good chunk of people like technology, music and art were okay, foreign language not so much. The individuals in this group would be the who, so we're talking about the students surveyed. Not the types of classes. The students themselves would be the individuals. So you break that down, you have 80 different data points. The variable would be what changes, and in this case, that variable is the type of elective. Now, I made a mistake in 8A, so if you're listening to this, be careful. This type of elective is it's not a measurable thing, all right? It's you do a survey, you have 5 choices. They had to pick a category. They had to pick something. It wasn't how tall are you? I'm 55 inches. It's not a number. These are numbers, but these are basically just the individuals. The category, the variable itself is categorical because it describes a type, basically a choice, okay? You have 5 different options to choose from. And categorical data isn't just multiple choice. It could just be like a yes or no, or it could be what city do you live in? And it could be a whole slew of cities and they just have to pick, where they are. So there could be thousands of categories in a survey. Quantitative is not the case here because we're not talking about something like what's your shoe size or how far of a commute do you drive to work? Okay, we're not talking about measurable items. We're talking about a topic. So this is going to be categorical. So I want you to be careful with categorical because categorical data, that's pretty straightforward. It's options, all right? A lot of times it's like words, not numbers. Quantitative is numbers, but there are some quantitative data points that aren't, there are some numerical data points that are not numbers, that are numbers, but that are not categorical, that are not quantitative. So think about like zip code, even though that's a number, it's not quantitative because it doesn't measure something. A zip code is going to be categorical. Okay, I hope that makes sense because even your salary, it's not a measurable thing, right? A salary, like let's say you make 50,000 a year, that's a categorical number because it's you are asked for like an income bracket you live in, not how much, how long is this or whatever. Like it's pretty set, and salaries can be flexible, as you know. So you got to be careful with quantitative. So we're going to go to Saplit. This is a great website, and I'm going to show you how to use Saplit to enter data in, so categorical data. So what we do is we go to one categorical variable, single group, and we always want to title it. So the variable name is going to be elective. There's going to be 5 categories. We got art, there's 10 of them. We got music, there's 9. And we can add as many categories as we want. So I'm going to add 3 more. We got physical education, 35. Foreign language, 4. And tech, which is going to be 22. Now, we want to make a bar graph and a pie chart. We're going to do way more than just those numbers, okay? So we're going to begin that analysis. Now, if you look at that bar graph and pie chart, you will see the frequency. And important on section 1.1, frequency is a count. Frequency is how many of whatever data points you have. If you look at that bar graph and you're asked to graph a bar graph, you got to be pretty consistent. So if I'm graphing this, I would not use frequency, to be honest with you. I would just use percentages. And you can change that by going over here. Notice that it says relative frequency, relative frequency. So let me explain the difference. And I'm moving on to section 1.1 really quick. A frequency is going to be a count. That's it. It's the raw data. The relative frequency, which is usually more important, is the percentage. You know, let's look at COVID-19 cases, right? Charlotte has a lot of COVID-19 cases, but does the percentage of COVID-19 cases for what Charlotte's population outnumber other cities? That's the question. That's the kind of thing you want to look at when you're looking at data. Yeah, Charlotte has a lot of people, so of course we would see more cases, if that makes sense. So when we're looking at data and we're looking at bar graphs and pie charts, I tend to err on the side of using percentages, okay? So let's do that. We're going to make a sketch here. Bar graphs, you want to label them correctly. I know there's not a lot of room on this page if you printed it out, but you want to be consistent with your width. And you want to be consistent with your labeling too. I do recommend counting by 5%, 5, 10, 15, 20. But if you notice, I don't have a lot of room on here. So you might want to change that to 10%, 20, 30, 40, and 50. Just because in this situation, you're limited space. And you might want to consider that when you're doing free response questions on an AP exam. So the relative frequency is what we'll label. And since I didn't put a percent symbol next to it, you can label that percent there. You want to label the bottom. So I'll say elective. And it doesn't really matter what, I mean, if you want to line them up so that it gets higher as it goes on, you can, but this is, I'm pretty sure, just putting it in the order you typed them in. So it doesn't really matter. We got art, music, PE, foreign language. Now you gotta be careful on this one because I think most people know what PE is, but FL could be like, well, why are you going to Florida? So be careful when you label them. And the last one being technology. So I'll put tech there. You can color code it if you want, but just be very careful with your heights. You know, if we know that art and music are relatively similar, but it looks like art's between 10 and 15%. So this is 10, 20, 15. Art's going to be about there. And music might be just a shade shorter. PE is at about 42%. So we're talking something like that. Foreign languages, you can hover over it if you want. It's going to be at about 5%. So halfway to 10. And technology is 27.5%. So something like that. And you can also make a pie chart. Now you don't usually, you're not going to make a pie chart probably on the AP exam, but if you were to make a pie chart, it would look like that. And you would color code it to whatever your liking would be. And I'm not going to go over that part because I think that one's pretty straightforward. You can hover over, it's going to be the same percents as the bar graph, okay? So we really do a lot with just one variable in statistics. A lot of time there's multiple variables going on. So here's a more useful breakdown. I'll go back up here and expand this for a little bit. So we're going to take these numbers and we're gonna split them up. So thinking about logically, like what, if you have a student that favors art, how many of them would be more English minded than math minded? Well, we had 10 art total. But I would argue probably that most would be more fan of English as a core class. So let's say that's 7 and 3 breakdown. Music, that can kind of go either way because I love music. I'm a musician, but I like math, and I think there can be similarities in music and math, but also the right brainness of the creativity of music could drive that as well. So since there's 9 people in music, and I would say they're pretty equal, I would make them close to each other if possible. PE, I mean, you can argue that a lot of people sports minded might be more logical, so it could be probably more math minded, but again, I think it's fairly straightforward. So 35 people in PE, 9 people in music so if I'm going to break that 35 down, I probably would say maybe 20 here and 15 there. Just throwing that number out there. And then the foreign language, probably, let's say they don't like math. So let's say there's like 1 person here and 3 there. And then the technology, probably more math minded. So out of those 22 technology people, let's say it's like heavy math. So let's say it's 18 and 4, okay? So taking a look at these numbers in the breakdown and just throwing these totals on here for a reference gives us more interesting data, okay? If I want to know what percent of all students who chose PE, well, first I'd have to know how many students there are. Now from the sum of these numbers, that total is going to be 80. So what percent of students chose PE? Well, that's 35, and that's going to be 35 out of 80. So you can do a little calculation here, 35 out of 80, since it does ask for a percent, and that's going to be 0.4375. So I would say 43.75. Now that is what we call a marginal relative frequency. And I'll talk more about that later, but we can write that down. Marginal relative frequency. Remember, frequency is counts, relative frequency is percents. Okay, percent of all students who chose math and chose art. So the word and is important here because that's including the kind of like the intersection of math and art. So if I look at math and art, there's only 3 people in that little subcategory that chose math and art at the same time. So that would be 3 out of 80 because it says percent of all students. And as you might imagine, that's going to be a pretty small percent. So 0.035375, which is 3.75%. What type of frequency that is called a joint relative frequency. It's joint because it's where they're combined. Joint is and, so joint is where they combine on the table to get you that. So if I did all the breakdowns of all these individual percents, those would be all the joint relative frequencies. All the ones from the subtotals here, the margins, those are marginal relative frequencies. And the last question, it says the percent of the students who prefer math. Notice that it kind of gives you a condition, right? It's just the ones that prefer math that chose technology. So what we have to do is we also have to add these counts up here. 3 plus 5 is 8, 28, 29. 29 plus 18 is going to be 47. And of course, if I add these up, that's 11. 11 plus 15 is 26, 27, 28, 29, 30, 31, 32, 33. And those two numbers should add to 80. So that's your total. So these four numbers add to 80. Usually we put our totals over here. So we would put the totals here, subtotals there, and then the final count usually goes in this right corner. So the last question, or this question, percent of the students who prefer math that chose technology. So I want to think about, just out of the math ones, what percent chose technology is going to be 18 out of 47. It's a pretty big chunk out of that group. You know, it's not quite the PE because there were a lot of people that like PE, but 18 out of 47 is 0.3829, or 0.383 if you want to round that 9 up, or 38.3%. That percentage also is a relative frequency, but it is called a conditional. Okay, condition is when you separate a column or a row and you do just out of that subtotal. So I'm going to write conditional. And let's look at this last question. How many variables does the table have? Are the variables categorical or quantitative? There's two variables. The variables are type of elective and type of core class. And as you might guess, those are quantitative, categorical variables. Man, I always get those two words confused, but they're categories because you chose math, English, or art, music, PE, foreign language, tech. These are not numbers, so these are categorical. This right here is called a two-way table. You're going to see two-way tables throughout the course. They're pretty common in statistics. There's a lot of comparison, and you want to be able to compare those two. So let me go back to Saplit now. So we got some data we can put in. And I'm going to change all my stuff here. We'll go to saplit.com. We're going to do two categorical variables. And I'm going to do math, or they're going to ask for explanatory and response. We don't need to know what those are right now, but we do want to kind of keep the table similar. So I'm going to say core class. And I'm going to say elective. Math, English, art, 3-7, music, 5-4, and we got to add 3 more columns, rows, PE, 20, 15, foreign language, 1 and 3, and technology, 18 and 4. And let me make this a little bit bigger and that a little bit smaller. And there's going to be a lot more data you can look at with this, okay? So we're going to start by thinking about the different types of graphs you can make. And I'll talk more about those graphs and how to draw them on the other notes. So before we go into that, let's go back and review a couple things. And then we'll kind of hit up what the numbers mean and everything. So in this section, you know, frequency is a count, relative frequencies are percentage. A bar graph and pie chart are pretty straightforward, and you can, I tend to err on using percentages for those relative frequencies. But you can use frequencies for bar graph. You can't for a pie chart. And a two-way table is just a you could use frequencies here or relative frequencies. And pie chart only use percentages. If you see pie charts that are not percentages, I would shy away from trusting it. A two-way table has two variables. With different data in there, and a lot of times you have counts at the end, summarizing everything too. Now, we're talking about types of frequencies, and I want to also review a few types that we talked about in the notes. So in the notes, you have marginal, joint, and conditional, and I'll define those a little bit better for y'all. So then I'll come back to the saplit and explain a little bit. So the joint is in a table. A joint relative frequency is like the individual cell divided by the overall total. So it's like the and, okay? So like in a table, all the joint relative frequencies would be each of the individual numbers, these 10 numbers here, divided by the overall total, 7 out of 80. How many people chose art and English? 7 out of 80, that percent. The marginal relative frequency are going to be the category totals over overall totals. So think about in the margins, okay? The sum of your art category over 80 would be how many people take art, prefer art. The sum of your English category, 33, that percent, that marginal percent, what percent took English? 33 out of 80. Those are marginals. And then finally, conditionals are what we do is we take the cell, the individual cells. So that's like the and, the joint. And then we put that over, not the overall total, we put it over the category or marginal. So basically you're taking the joint and dividing it by marginal to get the conditional, okay? So just remember conditional is if and then. If something happened, like if I'm only worried about math students, what percent like technology? That's a conditional. So let's talk about how to display these. Just to summarize it up, we got our two-way table. That's not super useful. Tables don't really make pretty data. So there's three different types of graphs you want to be able to explore and look at, and definitely use Saplit for now, but Saplit isn't going to be on the AP exam. So I want you to understand that when you're looking for it. So one of them is called a segmented bar graph. A segmented bar graph, all of your heights for each of the individual relative frequencies must be proportional to the actual percent. So you start by making a scale, and a lot of times 5 or 10 is the default count. And you're going to have two bar graphs. You're going to have your, in this case, your math and English. All right. So all of these individual percents, if you hover over them, now these are all backwards, so you got to be careful there. But that technology for math, that's 38.3%. Okay, so that technology for English, that's 12.1%. That's 4 out of 33. These are all marginal. Segment and bar graphs give you marginal frequency of conditional frequencies. I'm sorry, because they're only going out of your subtotals for these. Again, similarly, you could go through the other ones. Foreign language for English, 9.1. Foreign language for math, 2.1%. PE for English, 45.5%. Again, a lot of people like PE. PE for math, pretty similar number, 42.6%. And this is an important distinguish. You notice that percent smaller than that, right? Even though there are more people in PE than English, the percent of English students that like PE is slightly higher than the percent of math students that like PE. All right, the last couple, English and music, 12.1 and 10.6. All these calculations can be done just using straight division. And then the last one, English and art, 12.2 or 21.2 and 6.4. If you scroll down, you can see all those percentages. Okay, so that breakdown of all the individual joint relative frequencies are there. It also gives you the breakdown of the marginal relative frequencies into the total. It does not give you these 2%. Okay, so I'll explore that in a little bit. But these numbers here are marginal relative frequencies. These in here in the cells are joint relative frequencies. And conditionals are not provided. All right, so let's look at what we call a mosaic plot. Now, a mosaic plot is going to proportionally represent how many math people, in this case, are representative of the whole population. If you look at these two numbers down here, you have 47 math and 80 people. If you divide 47 divided by 80, you're going to get 58.75%. You're going to get more than half of that overall total of people because more people in this particular survey liked math. So a mosaic plot accounts for that. It gives it a little bit of a wider width so that it represents more people. So as you can tell, you know, even though there were a higher proportion of English people liked PE than math people, there still will be more people represented here because overall it's going to be a bigger width. So keep that in mind. Mosaic plots represent kind of, you know, a combination of segment and bar and overall percent of a category. And then we can do a side-by-side bar graph too, which is basically just putting all these percents together. You do all the math ones. These are the same percents that you saw on the segment and bar graph, and you have to make sure that they're scaled appropriately. And the same thing with the English. And so it gives you a very good visual description, and you might get questions that ask something like, hey, what's the difference in the conditional distribution of people who liked technology in math versus English? And so you could subtract those two. And I need to clarify that these percents here, if I didn't say it before, are actually conditional distributions, okay? So this 6.4, this 10.6, 42.6, 2.1, and 38.3, those are not joints, okay? So if you look at those, if you take 3 divided by 47, there's your 6.4%, okay? So these are all conditional frequencies, and your denominator is going to be 47. Same thing here, this 15 out of 33, that's not 15 out of 80, that's 15 out of 33 because there's only 33 English. So I wanted to clarify that because you got to be able to understand the breakdown of segmented bar graphs and side-by-side bar graphs and mosaic plots. They display conditional frequencies for the most part because it's the breakdown of those individual categories. So to summarize, you can do a two-way table to display your data. You can do a side-by-side bar graph, And those side-by-side bar graphs should display conditional relative frequencies. You can do a segmented bar graph, which is basically the side-by-side bar graphs stacked up against each other. So side-by-side. Kind of cool. I like the segment because they always have to add to 100%. And it has to represent all of the data here combined and stacked on top. You want to be consistent with which component or individual you're stacking on top. Don't put, if you're drawing a side-by-side or a segmented bar graph, don't put the tech here, and then for this English one, put the tech down there. You want to keep them on the same level so you can compare them how they work together, okay? The point is to make an analysis and a comparison. And finally, a mosaic plot, adjust the width to represent marginal percentages, marginal percentages. So at the very bottom of your columns, if there's more people in one column than another one, then that one should be a little wider. And you can adjust that. A lot of times that's just eyeball if you're doing it by hand, but obviously a computer program is going to make sure that that is pretty accurate. So there are more people here in math. Well, that's all I have for this lesson here. There are more data points and things that we can talk about, but I think that in general, that about sums it up, and I don't want to make this be any longer. So you should be able to do your 2 sapling assignments, 1.0 and 1.1, and holler at me if you have any questions. Have a good day.